Hello everybody, this is the first video for the week starting on July the 18th. That's the week for Module 4. That's when Module 4 is due, the assignment for Module 4. This one is probably the most complex of all assignments. And it discusses some very important things when we collect data through questionnaires using multiple indicators. So this is, I guess, the most sophisticated of the assignments. And a lot of the things that are discussed here are things that are useful for you to know and assimilate, because if you do this type of data analysis that you're doing here professionally and you use questionnaires, people will ask questions regarding things like convergent validity, discriminant validity, reliability, and why you measure those things. So this is explained in the video for the lecture, and it's also discussed in the textbook. I graded already for Module 3. Based on this grading that I've done, everybody completed the assignment on time and as required. So this time around there were no wrong answers. There was one late submission, but it was just late for a few minutes, so I'm calling it by the deadline. So everybody did very well in Module 3. This is a good class, so I'm very happy. By the way, the midterm that is listed here for this week is waived, so we will not have a midterm. As I told you before, if the class is going well, people are doing the assignments, then I have enough to provide to come up with the grades. If the class does not do well, then I may have to have midterm and a final to get a normal distribution of grades. The previous video, it looked like the second part of the video where I talked about minimum sample size estimation. It looked like it did not, there was a problem there. So let me repeat this in this video. Let me repeat what I said there in this video. This is, again, not required from any of the assignments. It's not something that you need to concern yourself too much regarding this course. But again, if you do this type of analysis professionally in the future, either as a consultant for organizations or working for your own organization, typically you're going to report your results to people who also know statistics, and they will ask you whether you have enough statistical power to conclude the things you conclude based on your analysis. So let me bring up the analysis that was done for this previous module. It was module 3 past week. So here we have the results, and if I go to view general results, I can see that the number of rows in my data set, and that's the sample size, is 500. So one question that someone could ask is, does your analysis have enough statistical power for you to conclude that all of these predictors are significant predictors of satisfaction? And this question is answered based on the lowest significant absolute path coefficient in the model, and this is the one here. Now, since this sometimes this gets crowded or it doesn't show properly, so you can get the results from here, path coefficients and p-values in table format, and I have also 3 digits. So the one that I'm referring to is this one, 0.183. So to answer that question, I have to go to Explore, Statistical Power and Minimum Sample Size Requirements, and then enter that number, that path coefficient, the minimum absolute path coefficient in a model, 0.183, hit enter, and the software is telling me that the more conservative method, the inverse square root method, is telling me that the minimum required sample size for this analysis is 185 for me to have a power of 0.8 or 80% and a significance level of 0.05. And that's what is usually done by convention. So these are by convention used for power and significance level. And the significance level here is the same threshold for the p-value that we use to ascertain whether a path coefficient is statistically significant or not. So the software is telling me that the minimum required sample size is 185. The gamma exponential method is more precise, so it tells me 172, but this is more conservative, so this is usually the one we follow. Since I have 500 as my sample size, then my analysis has enough statistical power. Now, this is a prospective analysis, prospective minimum sample size analysis, and this prospective means that I did the analysis already, I got the results, and then I'm finding out if the results I got are trustworthy from a statistical power perspective. They are. Now, let's say that I didn't do the analysis. Let's say I want to do what I just said is retrospective analysis. So I've done the analysis, I see the results, I establish that based on these results, my analysis has enough power because I have a large enough sample size. That's a retrospective analysis. A prospective analysis, before I do this analysis, I collect data, etc., it's usually done before you even are collecting data, and you want to find out how much data you need to collect. And if you don't know what your results are, because you may have an idea, for example, you may know that your results will be 0.15 and higher based on past research. But let's say you don't know what the path coefficients will be. Then what you do is you go to the option, Explore, Statistical Power, Minimum Sample Size Requirements, and then you keep this 0.197 as the one you are considering as the minimum absolute significant path coefficient. This one you are expecting to have, and then you get this minimum required sample size 146 to 160, but the more conservative is 160, so that's the one we would follow. So this is a prospective analysis. Now, it's possible that you do a prospective analysis and then you get 160, say, answered questionnaires or data points, and then you get results and you find out that 160 was not enough. So then what you would do is either collect more data or tell your customers that, for one of the path coefficients, you're not confident because you don't have enough statistical power. The reason I'm telling you this is that when you do this type of analysis professionally, typically the people that will listen to you in a company will not be the senior managers right away. It will be data analytics, internal data analytics folks who have these types of questions. And then the senior managers will listen to you and to them, but in a more summarized way, because then they will use your results to make decisions about the business. So this is all I have for today. Congratulations on everybody doing the assignment, completing it on time. This is a very good group, very good class, and I hope you are learning from this course. It's really important that you learn, because it's a time commitment you're making. You're paying for this course. I know that in an online course like this, some people cheat. It's just a total waste of time and money for them. And since we're not, as faculty, we can only catch so much cheating, right? So at the end of the course, I will have a graduate assistant do a full fine-combing, very careful review of all of the submissions, just in case there is a potential there for plagiarism or other problems. One thing I will say, though, is that if you don't want to give the impression that you are using AI to write these commentaries, a good idea would be to ask. I mean, you can write something and then ask AI to expand on what you've done. I haven't said that you cannot use AI. That's not something I said in the syllabus, so I'm not going to pick on this. But sometimes people who audit the course come to faculty and say, hey, you let the students use AI, and then I ask them, how do you know? And then they say, well, look at this, right? So AI, when you ask AI to write something based on something that is already available, and of course you already have text in the textbook for the course, AI often will do this itemization. And so this is typical of AI. And of course, I'm not saying that AI was used. Babitha could have done this without any AI. But if somebody is auditing this course, they will suspect that AI was used here. And then I will have to explain myself. Now, I do have something here. I strongly recommend for Babitha to redo this analysis, because remember, you have to set your analysis as linear. Okay, this has to be linear. If you set it as nonlinear, you get some variation, some different path coefficients. So your path coefficients should be very similar to these, right? So let me see what Babitha got there. 17, 52, 39, 24, 17. Yeah, they are a little different. This sometimes happens when the analysis is done in a non-linear way. So I would suggest to Babitha to just redo this analysis with that set as linear, and then see if you can get different results. I will consider the submission to have been done on time. I would just suggest that you reply to your own submission and then if there are differences, then attach the PRJ file and the screen snapshots. So this is something that you gotta pay attention to because it affects the results. In fact, let me do this right now. So I will redo this analysis just to see. I'll change the settings to Warp 3, which is the software's default. This is why this problem can occur. And then, yeah, that's the result. So those are the results that Babita got. So Babita and any other person who got results that are like this, 0.17, 0.39, these are if you set the analysis as nonlinear, and we're not doing this for this course. We're not doing nonlinear analysis. Sometimes there is a good reason for you to believe that a relationship is nonlinear, but that's not something we're covering in this course. So for example, this one, is quasi-linear, but this slight nonlinearity affects the results. Okay, so this is all I have for today. Thank you very much for watching.